Hi, this is Jeffrey Vasquez and this is Geotechnical Engineering. And in this video we will talk about vertical stresses in soils. Problem 2.
Problem number 2. A reinforced concrete water tank of size 10 meter by 10 meters and resting on the ground surface carries a uniformly distributed load of 250 kN per square meters. Estimate the maximum vertical pressures at depths of 10 meters and 20 meters by rectangular load approximation below the center of the tank using 2:1 method and Boussinesq equation. Now let's start with the 2:1 method. So um, we have the given distributed load of 250 kN per square meters and the dimension B 10 and then the depths of 10 and 20. So the formula for this 2:1 method is 4 square because we have a square water tank. So the change of pressure Z is equals to the point load over the quantity of B plus Z squared. So we need to find the point load Q, which is distributed load multiplied by the area. So 250 times 100 is equals to 25,000 kilonewton. So let's find the B plus Z squared in square meters. So the B is 10 and then Z is 10. So it's equals to 400 and the B is 10 and Z is 20, which is equals to 900. So we just need to divide this B plus Z squared into our point load, which is 25,000. So 25,000 kilonewton over 400 square meters is equals to 62.5 kilonewton per square meters. And as the depth goes 20 meters, the pressure also decreases, which is equals to 27.778 kilonewton per square meters. Now the second one is the Boussinesq equation. We have our given here 250 kilonewton per square meter, our distributed load, and then our L and B. So take note that our B here should be the shorter dimension and L is the longer dimension. So since this is a square, so both of them have the same dimension, so it doesn't really matter. And also, we have to take note that the problem seeks for the load approximation below the center of the tank, which means that we need to find I4. So we need the table I4. So in finding I4, we have B, which is equals to capital B over 2. So 10 over 2 is equals to 5. And Z is given 10 and 20 meters. And then we have M1, which is L over B. So 10 over 10 is equals to 1. So 10. Both of them are 1. And then N1 is Z over the small b. So Z is 10 over 5, which is 2. So and 20 over 5 is 4. Now, we have our values for M1 and N1 here. So let's find it on the table I4. Now, M1 is 1 and 1 is 2. Now, here is 0.336. So, and M1 is 1 and N1 is 4, which is equals to 0.108. To solve for the pressure, we just need to multiply load on the center, which is 250 kilonewton per square meters, by the I4. So 250 times 0.336, which is equals to 84 kilonewton per square meters, and 250 multiplied by 0.108 is equals to 27 kilonewton per square meters.